Hello, I'm back with rusting of iron, okay? So this is the second part of rusting of iron, okay? And this part is very interesting, okay? In this part, we want to talk about the effects of other metal or rusting of iron. Okay, before we can discuss about the effect of other metals on rusting of iron, we have to be very clear about our ECS. This is our electrochemical series, okay? As you go up, the electropositivity increases. If I say the electropositivity increases, this means that the metals on top in the ECS, they have a tendency to donate electron and form positive ions. Okay? So tendency to donate electrons and form positive ion. Tendency to donate electron must be oil, oxidation, loss of electron, and this must be a very good reducing agent. Okay, so what I'm going to do, I want to investigate what will happen when zinc is in contact with iron. So I am putting a metal which is above iron in the ECS. Of course, zinc is more electropositive than iron. So what will zinc do? Zinc will donate electron. See my keyword, atom. Donates electron. The moment it donates electron, there's an oil there. Okay, there's an oil. So it will be oxidized to Zn2+. Zinc donates 2 electron, oxidized to Zn2+. Okay, since zinc is the one that donates electron, the zinc corrodes instead of the iron. So the zinc protects the iron. So it acts as a sacrificial anode or metal. When I say sacrificial anode, why anode? Donate electron, you become a negative terminal, okay? And the negative terminal is known as anode. When a metal is in contact with iron, okay, what is the reaction that is taking part is just like a reaction in a simple cell, okay? So at the negative terminal, there is electrons being donated, okay? Since zinc is the one that donates the electron, the zinc corrodes, and you remember, it protects the iron. So straight away, you must know down here there is no rust. No rust is being formed down here. That is very important. Okay, the second part. The second part, okay, the second part is, okay, when electron is being donated, what will happen to the electrons? The electrons will flow to the iron since the zinc is being partnered with the iron. Okay, iron in contact with zinc, so the electrons donated by the zinc, okay, flow to the iron where there is water and oxygen. So the oxygen that has dissolved in the water gain the electrons, gain. So the moment I say gain is a rake and is reduced to hydroxide ions, okay. So the oxygen dissolved in the water gain the electrons and is reduced to the hydroxide ions, okay. Looking at this simple explanation, you notice that, okay, when iron is in contact with a more electropositive metal, rusting is prevented or inhibited. So if you want to protect your iron, you connect it or you put it in contact with the metal above it. Okay, not the very electropositive one, okay? Around here will be okay. So when you put in contact iron or you wrap iron or you coil iron with a metal that is above it, you notice that rusting is inhibited, okay? What will happen, okay, if you were to put iron with a metal which is below it? Okay, let's say if I were to take iron, okay, I put it in contact with copper. So you know iron is more electropositive than copper, definitely. So this is more electropositive. So what will it do? Donates electron and form a positive ion. Donate will be oxidation. Okay, so it donates electrons, so it's oxidized. So the moment it donates electron, this is the first step in the formation of rust. Okay, straight away the iron will rust, okay, and nothing will happen to the copper. Okay, the next step, again the same thing, the electron flow to the oxygen which has dissolved in the water, and then hydroxide ions are formed. Okay, the Fe2 plus combines with the 4OH minus here, with the OH minus, okay, combines to give you iron 2 hydroxide, which is a green precipitate, okay. So further oxidation by oxygen in the air will change it to hydrated, okay, iron 2, okay, iron 3, hydrated iron 3 oxide, okay, hydrated iron 3 oxide, which is actually rust. Okay, and this one is brown in color. Okay, hydrated iron 3 oxide, which is rust. And then if you think carefully about it, if you take iron and you connect it with the metal above it, rusting is inhibited. Okay, so rusting is prevented. But if you connect iron, you put it in contact with the metal that is below it, you notice that rusting is faster here. Okay, rusting is faster. So when iron is in contact with the less electropositive metal, of course rusting is faster. Okay, so you want to protect your iron, what shall we do? We are going to wrap it, we are going to wrap a more electropositive metal around it. If you want rusting to take place fast, okay, what must you do? You wrap your iron with the metal below iron in the ECS. Okay, so to investigate this simple idea of when iron can rust and when iron does not rust, okay, to investigate this idea or the effect of other metals on rusting, okay, what can we do? We can carry out a very simple experiment. Okay, so the problem statement is, what is the effect on rusting when iron is in contact with other metal? Your hypothesis will be, when you have a more electropositive metal in contact with iron, the metal inhibits rusting. When you have a less electropositive metal, the metal speeds up rusting. Your manipulated variable, you're going to change your metal in contact with iron. You are going to, responding variable is the intensity of the dark blue coloration. Okay, this dark blue coloration is actually potassium hexacyanophrate 3, okay, when reacted with iron 2. So the first step of rusting is the formation of iron 2. So iron 2, okay, when reacted with potassium hexacyanophrate 3, you will get a dark blue coloration. Okay, your fixed variable here, your fixed variable is equal to your iron nail. Okay, so your fixed variable is your iron nail. Okay, how you want to do the experiment? Okay, you take 5 test tube in all, okay, 5 test tube, okay, 5 iron nails, okay, and magnesium ribbon, a zinc strip, tin strip, and copper strip. Okay, all the iron nails and the strip and the ribbon, I want you to clean it first with sandpaper. After you clean it with sandpaper, you drop it into the test tube, okay, and you pour equal volume of hot jelly solution to which potassium hexacyanophrate 3 solution has been added, a few drops, and a few drops of phenolphthalein. Remember what I told you about the potassium hexacyanophrate 3? It is to detect the presence of iron 2, which is the first step of rusting. Okay, and the phenolphthalein is to detect the presence of the hydroxide ions. Remember, the electrons from here is being passed to the oxygen that has dissolved in the water to produce hydroxide ions. Hydroxides with phenolphthalein will give you a pink color. Okay, Fe2 plus with potassium hexacyanophrate will give you a dark blue. Okay, will give you a dark blue coloration. Okay, so once you have set up the experiment, okay, you leave it aside for, let's say, 1 or 2 days. Okay, after 1 or 2 days, let's look at the results. Okay, the first one is just iron by itself. The next one is iron in combination with, in contact with magnesium. You have coiled the magnesium around the iron. The next one is iron coiled with zinc. The next one is iron coiled with tin. And the next one is iron that you have coiled with copper. Okay, so if you look at the intensity of the blue coloration, okay, A is the control experiment. Okay, rusting has taken place, but not much, very little, okay? Definitely the inference, the iron rust. B and C, you are combining with a more electropositive metal. So no rusting, no blue, okay, no blue coloration, but high intensity of pink, which indicates the presence of the OH minus. This is the OH minus. Okay, D and E, you should have blue coloration, but E is higher. So if you think about it, okay, if you look at your iron, this is your iron, okay, this is your tin, and this is your copper. Look at the distance between iron and copper. The further apart the distance between the two metals in the ECS, the faster the rusting. So this one should have more rust, okay, faster rate and more rust. This one is very close to one another. So the rate of rusting still take place, but the rate is lower compared to iron and copper, because the distance, okay, between these two metals in the ECS is not that far compared to the distance between iron and copper. Okay, I have chosen two to explain to you how to go about doing the explanation. Okay, the first one, okay, is the iron nail with magnesium. So you get high intensity of pink spots. The moment you get pink spots, the pink spots indicates the presence of hydroxide ions. No blue spots, okay, no blue coloration. Since you don't have no blue coloration, okay, so my inference, that means there is no Fe2 plus ions. Okay, no Fe2 plus ion, because you don't have any blue coloration, so there's none. So in this case, does the iron rust? The iron does not rust. Okay, so you can do that very easily. Okay, how are you going to do about the explanation? How are you going to explain this process? Okay, very simple. You just look at magnesium, you just look at iron, you ask yourself which is more electropositive. You start with the sentence, okay? So magnesium is more electropositive than iron, first step. Second step, magnesium donates 2 electrons to form Mg2+, okay? Oil, don't forget, oxidation. Okay, the electron flows to the ion and is gained by the oxygen which have dissolved in the water, okay, to give you hydroxide ions. Okay, so can you understand that part? So which is the substance that is going to corrode? So in this case, your magnesium corrodes and your magnesium protects your iron. So magnesium acts as the sacrificial anode. Okay, let's look at another one. Okay, another one down here is a combination of iron and copper. So when you talk about iron and copper, you notice you have a high intensity of blue coloration. So the moment you have high intensity of blue coloration, blue, this one indicates the presence of what? Okay, by now you should be able to tell. Okay, so the moment you've got a lot of blue, this indicates the presence of iron 2. So the moment you have blue coloration, high intensity of blue coloration, this one indicates, okay, or shows the presence of, okay, this one shows, alright, pendek, shows the presence of Fe2+. Okay, when you have Fe2+, you must straight away tell me the iron rust. Okay, how you want to go about doing the explanation? It's very simple. You do the same way. You just look at the pair that we have down here. You have iron and copper. Just ask yourself, who is more electropositive? Iron more electropositive than copper. Second step, what will iron do? Iron donate electrons to give you 2 electrons down here. Okay, then what happened? The electrons will flow to the copper and is gained by the oxygen that has dissolved in the water. Okay, to give you what? To give you, okay, hydroxide ions. Okay, to give you hydroxide ion. Combine these two together. Don't forget, this is your oil and this is your rig. Okay, keep remembering that. Okay, next step, you combine your iron 2 plus, okay, plus your hydroxide to give you iron 2 hydroxide. Iron 2 hydroxide, which is a green precipitate. Okay, further oxidation by oxygen in the air changes it to rust. What's the formula for rust? Iron 3 oxide dot H2O, hydrated iron 3 oxide. Okay, so what can we learn from this experiment? We can say that if you want to prevent rusting, what must you do? You take your iron, you put it in contact with a metal which is way above it. Okay, but if you want rusting to take place at a very fast rate, what shall we do? Okay, if you want rusting to take place at a very fast rate, you put it with a metal which is below it. Okay, so these are two very important experiments. So I hope you go through and able to understand it well. Okay.